Now let's discuss the energy band diagram of two closely spaced atoms. Here you can see there are two energy band diagrams for two different atoms which are closely spaced. But in this situation, the separation between the two atoms is so large that energy of one electron in one atom is not affected by the other. That's why both of these curves are approximately rectangular hyperbolas because these are almost in the influence of their individual nuclei which are located at the center. So here y-axis is representing potential energy and along x-axis we are talking about the distance of electron from the center. Now these dotted lines here are representing energy level for the orbitals 1s, 2s, 2p and 3s respectively. Now let's see what happens when the two atoms are brought close to each other. Here you can see that when these atoms are getting close, after a separation decreases below a specific value, here you can see that overlapping of orbitals between the two atoms start, and as separation decreases, overlapping increases. At this situation, we can say that the two atoms are at such a separation where the 3s orbitals are overlapped in this zone and the 2p, 2s are in the influence of the individual nuclei only. So here we can state in this situation the electron which exists in 3s orbital is free to move in the whole combined 3s orbital, or this is a molecular orbital we can say, in which there is a common orbital where electron is allowed to move. But the electron which is moving in the influence of an individual atom, that is in 2p and 2s, is not allowed to move into the other atom zone. But those electrons which exist in the orbital 3s or any orbital above, we can say if 3s is in the overlapping region, all other orbitals which are in the zone above 3s can also be considered as these electrons which are allowed to move in both of these atoms. So we can say this is the point X where the two atoms potential energy is getting equal exactly midway between the two. All the orbitals which are about this point X or where potential energy is more than this X value, we can say that electrons are free to move in any of these orbitals, or the orbitals will combine and form a common orbital. This is the basis we are going to use to understand how orbital structure exists in case of a solid lattice structure. Let's take it up in the very next article. Here in continuation we can see a realistic situation also when two atoms are brought close to each other. Here you can see there are two atoms, and when these are brought close to each other, initially they are having their individual electron cloud associated with the individual nuclei, and when these are getting close to each other, when their electron cloud, outer zone of this electron cloud starts getting overlapped, we can say a common cloud will be there in the outer zone of these two nuclei, and in the inner zone you can see that electrons in the lower orbitals, like which we have seen in the above figure, 1s, 2s or 2p, which are not getting overlapped, are associated with the individual nuclei, and the outer orbitals, like in the above figure, we can see 3s and above, all above orbitals where which are getting overlapped, you can see it is forming a common cloud. So this is a situation which you can realize in practice. You just keep it in mind for your imagination, like whenever atoms are brought close, the upper diagram shows energy band diagram of two closely spaced atoms, and this lower picture gives you a three-dimensional idea about how the electron cloud sharing takes place, or due to overlapping a common cloud is formed, which we generally term as molecular orbital.